All right, in section P5, we're gonna do some review over our factoring skills. So we're gonna start by looking at common factors, okay? So we wanna factor out the greatest common factor. For number one, that's very straightforward. You probably feel pretty good about how to do a problem like number one. In this case, the factor that we can take out of everything, just go one term at a time. Start by looking at the coefficients. 18 and 27, I could divide out a 9 from both of those. Then I look at x cubed and x squared. We always take the least power because we can't take more than what one term has to offer. So x squared is the least power from all of those. And now I just divide it out. 18 divided by 9 is 2. X cubed divided by x squared leaves me with 1, plus, because it's positive, 27 divided by 9 gives me 3, and the x squared, I divided out the whole thing. So that would be factored in terms of the greatest common factor. For number two, it's not quite as straightforward, but this is more the types of problems that we're going to start seeing. The factor that these both have in common is x plus 7. So we can factor out, x minus 7. Factor out the x minus 7. If I divide the first term by x minus 7, that's going to be divided out, so we're just left with 2x. And if I divide the second term by x minus 7, we're just left with plus 3. And so now, ta-da, we have the factored form of this expression by factoring out x minus 7. Number 3 has a little bit of everything. So remember that multiplication connects terms. Addition and subtraction split apart terms. So even though there's multiple factors happening here, there are only two terms because there's only one plus that divides them. The multiplication hooks everything together. So let's go down the line. First, let's look at our coefficients. What goes into 16 and 4? And the answer is 4. Now I've got an x cubed and an x. Remember, we can only take the least power, so that would be x to the first. What else do they have in common? They have an x minus 1. But this first term has a squared, and the second one is only to the first power. So again, that's my least power is x minus 1 to the first. Now, the second one has an x plus 2, but the first one doesn't. So since they don't both have it, we cannot combine that, or we can't take it out from both terms. So what we're going to do now is we're going to come up here to each of these terms and divide by 4x, x minus 1, because that's the GCF. We do that in our head on most problems, but sometimes it's helpful to write it out. So let's see what we have left. Work one piece at a time. 16 divided by 4 is 4. X cubed divided by x is x squared. And if I have two of these and I cancel one of them out, I'm going to be left with x minus 1. Plus, the 4's cancel, the x's cancel, the x minus 1's cancel, and I'm just left with x plus 2. Now let's look at what's inside these parentheses and see if we can simplify, which it looks like we can. So we now have, if I distribute 4x to the third minus 4x squared, and then there's nothing to distribute here, so it's plus x plus 2, and that's going to be the most factored form of that expression. Why would we want to do that? Because it looks like it got messier. We've gone now from having two separate terms to one term that is built by a collection of factors. Everything in that is a separate factor now. 4 is a factor, x is a factor, x minus 1 is a factor, and all of this stuff that's left is a factor. That's important, okay? All right, so factoring by grouping kind of falls directly from this idea. When we factor by grouping, in Algebra 2, you're pretty much taught that you split it down the middle. That's because that what usually makes the most sense, but it doesn't have to. You can split it 3 terms and 1 term, or you can split it 1 term and 3 terms. It just depends. But in this case, when you see that you have a trinomial that goes cubed, squared, linear first, or constant, then splitting down the middle makes the most sense. We'll see some examples later on where grouping it differently makes more sense. When we do that, 4 terms, factor by grouping, now we want to look in each half and see if there is a GCF. So the GCF of the first half would be x squared, so I get x plus 5. The GCF of the second half, the rule is that if your leading coefficient is negative, your GCF must be negative. So we definitely want to factor out a negative, and we can take out a 2. If I divide both of these by a negative 2, that's going to change the sign on both of these. That is good because now we can see we have a pair of common factors similar to the problem that we did up above. So if I factor out the x plus 5, then what I'm left with is x squared minus 2. And now this polynomial is factored. So factor by grouping means split it into 2 groups. Typically you're going to split it evenly, but not always. And that is how you're going to figure that out. The last thing today is to review factoring our trinomials. Okay. So when we are factoring trinomials, guess and check is always a great way to do it if you can do this in your head quickly. And this is something I'm going to be pushing you this year to think about how you can set this up. So this strategy that's here in the box is probably how you learned to do this in your Algebra 2 classes. Now, everyone sets it up kind of differently. I always set up these X's, and I don't know if you've seen that in your classes before. On the top of the X is always going to be A times C, and on the bottom of the X is always going to be the value of B. What you are looking for is 2 numbers that are going to multiply. We want them to multiply to be equal to the number on the top, and we want them to add to be equal to the number on the bottom. That's kind of hard to see on that gray background. So you want them to multiply to the top, add to the bottom number. That's what we're looking for the 2 numbers on the side. And I'll walk you through how to do it that way in just a minute. But I want to show you how I do these in my head, okay? When you think about factoring by guess and check is going to be really helpful whenever you have a number on either end that has very small factors. So at the beginning, I have just x squared. The only way that I could multiply and get x squared is if my factor started with x and x. Okay? Think about what we talked about with FOIL. This has to be the first, this has to be O plus I, and this has to be the last. So the last has to multiply this number times this number has to equal 8. There's more than one way that we could get 8. And so in my head, I kind of go through some guessing and checking. Let's think about 1 and 8. And I don't normally write this down. I just kind of think to myself. Think about the outside and the inside. In this case, outside would be 8, inside would be 1. Do those add or subtract to 6? And the answer is no. So it can't be 1 and 8. Maybe let's try 2 and 4. So the outside gives me 4x, the inside gives me 2x, and if I add those, I do get 6x, so I know that I want pluses inside both of these factors. And so there's your answer. Okay, so that's a fast way that if you really start practicing with factoring, you can get this done. On the AP exam, they don't want to see little diamonds and X's drawn out to the side. They just want you to get the factors. So put the video on pause. Challenge yourself today. If you don't like it this way, you can do it the old way later. But I want you to pause the video, challenge yourself to be able to factor this one without writing it out. See if you can factor it in your head. All right, hopefully you took a second to try that yourself. Here's how I would think about this. Again, it must be x and x. That's the only way this will work. In order to multiply to negative 18, I need one of my numbers to be positive and one of my numbers to be negative. So that's something that we need to think about. We need to be able to subtract to get 3x instead of add, since one of the numbers has to be negative. So I need to think of things that multiply to 18. 1 and 18 seems like that's going to be way too big. So maybe let's try 2 and 9, and you think that in your head. So I get outside 9x, inside 2x. If I subtract those, I get 7. Doesn't work. So it's not going to be 9 and 2. How about 3 and 6? Outside is 6. Inside is 3. If I subtract the 3 from the 6, I do get 3x. So since I need to subtract the 3, I want this one to be negative and this one to be positive. And that's how we get our answers, okay? Let's look at number 7. I'll show you how I do this one in my head. Again, this has a pair of factors that are pretty small. If you look at 6x squared, the only way that you can get 6 is 1 times 6 and 2 times 3. If you look at the last, 7, the only way we can multiply to get 7 is 1 and 7. So that's where I'm going to start. The things that I know for sure is that it's going to be something times x, and one is going to have a 7 in it, and it's going to be something times x, and the other one has to have a 1 in it. That is how it must work. One of these numbers has to be negative, since when I multiply, I need my answer of 7 to be negative. So the number that we're choosing is this space right here, which is how do I multiply to get 6, okay? So let's think. We need to get to 19 in the middle. If I put 6 and 1, outside gives me 6x, inside gives me 7x. That does not subtract to give me 19, so that doesn't work. What if it was 2x and 3x? Outside gives me 2x, inside gives me 21x, and if I subtract, that does give me 19. I need positive 19, so that means I need the 21, 7 times 3x, to give me a positive number, and 2 times 1 needs to give me the negative number. So there's my factors. Now that's how we can do that by using guess and check, which is a whole lot faster. It doesn't feel faster now because you've never done it this way before. But the more you practice with this, the faster you will get, and it will surpass the other method. The other method is this. Let's walk through it on this one just to be sure that we all know how to factor. I would look and say on the top, 6 times negative 7, that's A times C, is negative 42. And the bottom number is B, which is 19. I need to pick two numbers that multiply to negative 42, but add to positive 19. And guess what those are? 21 and negative 2, which we kind of saw where that happened in our guess and checking process. So what we do with this now is we take out the middle term that was 19x, and we replace it with those two side numbers. So we have 6x squared, then we're going to have plus 21x minus 2x, and then the last number is the same, minus 7. Now we have a situation where we have 4 terms, so we go to factoring by grouping. So I can factor out a 3x here, so I get 2x plus 7. And I factor out nothing in common, but remember the rule, if it starts with a negative, I have to factor out a negative GCF. And so I get 2x plus 7. There's our common factor. So when we factor out 2x plus 7, we're left with 3x minus 1. And there's our factors. And so you can see we got the same thing that we did when we guessed and checked. Let's do it that way on number 8 as well. This has 3 terms, and I noticed that the pattern, it's not a quadratic, But this is essentially x squared squared, and this is x squared to the first, and the last term is a constant. So it's in quadratic form, if you remember that from the polynomials last year. This one would be a great candidate for guess and check, since you can only get 3 one way, 1 times 3. So I would use guess and check here. I wouldn't mess with factoring by grouping, but let's practice that as well. So we have negative 24 on the top and negative 10 on the bottom. So the numbers that I get here are 2 and negative 12. Negative 12 times 2 gives me negative 24, and negative 12 plus 2 gives me negative 10. So remember, we take out the middle term, leave everything else the same, 8x to the 4th. Now I want, since there are x squareds in the middle, that's what I need to replace it with. So I have plus 2x squared minus 12x squared, and then we have minus 3. This is 4 terms again, so now we split it down the middle and factor out our GCF. 2x squared times 4x squared plus 1 minus 3 times 4x squared plus 1. Again, so our factors are 4x squared plus 1 times 2x squared minus 3. Okay? Number 9 and number 10 are really, really similar. You just have an xy in the middle term. As long as the two outsides are squares, x squared and y squared, they'll be fine. I would do this one. You can certainly do grouping. Your two middle terms would be xy, xy after you set up your x there and figure out what you want. But since 2 is only 2 times 1 and 3 is only 3 times 1, I would guess and check here. I know this is going to be a 2x and an x. And then I know that I need a y on both sides. That's how I'm going to get y squared. I just need to decide which one of them should be 3 and which one of them should be 1. Let's try 1 and 3. The outside would be 6 and the inside would be 1. Those are going to add up to 7, but we need it to be a negative 7. If I need this to multiply to a positive, that means I can make both of these negative. So we get 2x minus y, and x minus 3y is the best way to write the factors. I'm going to leave number 10 to you to look up in the notes yourself. That is a quick crash course review on factoring, which is a very important skill as we move forward.